Good afternoon. So I'm going to talk about quality assurance in video distribution. So in recent years, we have been working with a lot of content producers. For them, quality video distribution means preservation of creative intent or preservation of artistic intent, because that's something they care about, because they spend so much time in their studio trying to figure out everything, make everything correct, make all the pixels, all the colors as they wish. But they are concerned about whether this creative intent has been kind of distributed to final users' devices like their TVs and cell phones. Right, so what they really care about is trying to tracing the quality degradation from the source, which is right at the point they produce the content, and compare that with the playout. Playout means that the playout of the video at consumer devices. Right, so indeed, we have been working with American Society of Cinematography. Actually, ASC has a Motion Imaging Technology Council. They have formed a SIMWave HDR evaluation working group. And the purpose of that group is to assess, evaluate, and improve the preservation of original creative intent of HDR, WCG, and Ultra HD digital motion picture imagery during the video distribution and delivery from grading to consumer devices. Right, so we have been working on the project. This is still an ongoing project, but we have been working on the project for quite some time. Okay, so for the SIMWave HDR evaluation working group, these are the things we're doing. So we're going to do both subjective testing and objective evaluation. In particular, the method that has been chosen to do the quality evaluation is the SIM+ metric produced by SIMWave. And we're really interested in doing the comparison between the S-graded content, which is something produced at the studio. It's exactly the content that produced by the user, not even have any distortion. So this is here we're talking about something not even the magnifier, it's the raw pixel file. Right, so compare that with the content that has been distributed to the final consumers' devices. Right, so we're going to talk about some testing methodologies and the outcome we have up to this point. Right, so the first thing is why we're choosing SIM+ as the metric to do this evaluation. So for those of you who has been be interested in studying video quality metric, maybe you have know my past work. I've been working in the field in the past 20 years and produced quite some video quality metrics, and including SSIM, multi-scale SSIM, and so on, and many, many others. Right? So what we do is to produce an algorithm, like the current SIM+, the latest metric we have been using. It's an algorithm that watches the video pixels, just like human eyes are watching at the video pixels, and trying to predict viewer experience in real time. So SIM+ is running really faster than real time. And the purpose is to design such metric that can exactly predict how humans would rate video quality. Say the humans can rate the video quality to be bad, poor, or excellent and good. We are hoping that algorithm can say the same language. And in the past, we have done a lot of testing, and this method has been refined many, many times. And now they can do a very high accurate prediction of perceptual quality, and has many, many other functionalities. Right, so the fundamental methodology, we don't have time to go deep into that, is the fundamental technology is to use human visual system models in the algorithm, and trying to predict how humans think about the quality of the video. Right, so we don't have time to get deep into the method, but we can show some example what it is producing. So this is the one thing that we can expose from the algorithm. So the algorithm actually produce up to pixel level quality maps. So for example, on the left-hand side, you see a compressed video video frame, and then even from distance, I guess you guys can see some distortion, say the blocking artifacts in the sky, and actually at the bottom you see a lot of blurry and lots of details. On the right-hand side is what we call the quality map. It tells you up to at each pixel level what the quality level of that particular location in terms of visual perception, right? So Simplus is actually the only method in the market that can do this kind of job up to pixel level. Every single frame, every pixel, you know the exact quality. And this gives you some more example that's relevant to HDR kind of content. Say, for example, you have the same HDR content, you do different kind of tone mapping algorithms, apply to that, in the end you got different appearance of these content, right? So you look at each one of them, some of them look too dark, some of them look too bright, have some color, brightness, saturation, some of them is losing the details in the shade, and there are some middle one, they look overall okay, but still you see some loss of details, right? So what Simplus is doing is to take that picture and produce, again, in this case, multi-scale quality map. Right, so this is not just one quality map, but also the quality map at different scales. Different scale, of course, corresponds to different viewing distance, for example. Right, so that tells you, again, brighter here means better quality, darker means worse quality. So it basically tells you, so for example, like the top one is not perfect because you see some darkness in the background, so which means some background information has been lost during this tone mapping process. And the bottom one, again, looks overall, the overall brightness looks better, but if you look at the middle window, in that window region, you will see that the details in that window, right, so got lost. It's all bright in the middle. That means you lose some information. And this problem has been identified by the quality map. If you look at the quality map, the center part you see a disk, a dark disk over there, that means it's detected this region has bad quality because all the details in that window has been lost. Right, so this gives you some more flavor about exactly what's happening inside that Simplus algorithm and why this is a good match to the HDR type of content. Okay, so this is what we do, and so basically, as I said, we're not even starting from the magnifier, we're starting from the very linear light pixels, from ACES OpenEXR, half-floating kind of pixel level kind of content. This is HDR and UHD, not UHD, 4K, exactly 4K content and Rec 2020 content. And we do some conversion to PQ encoded RGB 444 Rec 2020, and then we also mapped that to 12 bits per component. And then after that, we want to simulate what's going to happen in terms of video quality degradation in video distribution. So in this part, we can basically do whatever we want, but we really want this part to be as close to video distribution as possible. At this point, all we do is to do some simulation, because in the real world, we can imagine this has to be at least 2 times of compression, right? Because you got information, you got the content from raw pixels. At least you're going to produce a magnifier that's 1 time of compression, and then you go to distributor. Distributor is going to do another round of transcoding and so on, right? So, but at this point, what we are really interested is to produce a testing methodology. So what we do is do a compression on that file, and then we converted that to 420 10 bits. And then after that, we produce this content. We revert the whole process such that we can see that this as distributed content in the same way as graded content using the reference monitors that's been using in studio. In this way, we can check whether the video distribution process can have some impact on the quality of the video being distributed. Right, so these are some user interface we have been using. Actually, the whole description of this could be pretty long. So basically what we do is we basically use 2 monitors. One is a reference monitor that has been used in the studio. Right, that's the right way to visualize HDR content in studio. And we have the before and after distribution as graded versus as distributed video. On the left and right-hand side, we have a sliding hairline that move in the middle so that you can do a straightforward comparison on the left and right. On the other screen, we're showing the quality map we have been producing using the Simplus method. Actually, on top of the Simplus quality map, we also have color distortion map. That's a separate map. You can switch between these two types of maps to see the difference. So you get a very, very detailed visualization about exactly what's happening of each pixel, each frame, each pixel, what's happening between as graded and as distributed video content. And then you also got space to scoring, put comments, and so on. Right, so, and this is showing the interface. And then in the end, we're going to do this subjective testing. This is still ongoing. We're going to do this subjective testing, not with common naive viewers. We're going to do this with DPs and colorists because these are their content. That's why they're doing this. They really care about whether their content has been faithfully distributed. So they're going to be the subjects looking at this. Some of these content that are produced by exactly the same person. So they are the golden eye of the golden eye, right? So basically, they have the final say about whether my creative intent has been preserved, right? So this is going to be the testing process. So as I said, this is ongoing, but so far we have already been able to see what we can do with this approach. So basically, we have already been able to detect like texture distortions. So for example, loss of texture details, compression artifacts, and so on. We can also do color assessment. So like skin tone change, we can detect that. And the effect of color format and gamut change. If you, in your workflow, you go from Rec 2020 to 709, then you go back, you pretend nothing happened, then this one will detect that. Right, so, and also detecting the highlight details, color, brightness, saturation, and the loss of details in the dark. And also, even if you, some very tiny subtle change, even if you do 444 to 420 conversion, and then you convert it back, and this method is also able to detect that in some very specific locations. Right, so this is what we're going to be talking about today. Thanks.
Thank you.